So very good morning, students. Welcome to IIT NEET Foundation, our Focus C program by Krishnaveni Talent Schools and the Mastermind Schools. So once again, I welcome all the class 9 students so far from Jogipet branch for today's session. As you all can see on the screen, and you are well aware, my subject is physics. We are in class 9th. Our ongoing chapter, the 7th chapter, fluid pressure. We are today entering into the session number 2. Means so far we completed one session, the one class in introduction of the word fluid and pressure separately. Right? Fluid is a different thing, pressure is a different thing. But when those two are connected, we have to read that what kind of pressures that fluid can exert. Combination is different. But in last class, we discussed only about the introduction part of the both. So when you see the matter, right? Matter is the one which has weight and occupies some volume. It may be either solid, liquid, or gas, right? This is called the matter so far. Of course, some more are there. We'll come across higher classes. So out of these solids, when you place solid at one place, for example, you place the pen at one place, can it flow? No, it can only move, but it won't flow. But whereas liquids and gases, they always flow. So that's why both liquid plus gases together are called fluid. Both liquid and gases together named as fluid. Right? Because they flow. They flow. They are not having the resisting force like solids. Because in solids, all the particles are tightly packed with a particular geometric structure. There is a resistance power in that. But whereas in liquids and gases, there is no resistance power, so they flow. That is the reason both liquids and gases together called as fluid. Right? Then you know the word pressure. Before pressure, you should know what is thrust. Thrust is nothing but force only. Force acting perpendicular to the body. A perpendicular force is called thrust. When you are hitting the nail into the wall, you want to insert the nail into wall, you apply the thrust, right? So that is called thrust. Yes, what is the problem? Jogipet? So thrust is nothing but a force acting perpendicular to the body. And whereas pressure is nothing but the thrust per area. When the force acting perpendicularly on a particular area, so when you are hitting the nail, so we are hitting the head of the nail with the help of the hammer. That small area the force is acting and making the nail to insert into the wall. That is called pressure. So pressure is nothing but thrust per area or force by area, which is measured in either Newton per meter square or Pascal. Of course, so many other units also there for the pressure we'll discuss today. So we came to know in the last class about what is fluids or what are fluids, what is pressure, before that what is thrust and area, right? That we can see on the screen also. This is the first page of our material. Okay, so we can see what is the introduction of the fluid. Clearly says there are mainly exist three physical states: solids, liquids, and gases. Solids have a definite shape and size, while liquids and gases do not have any definite shape. But liquid and gases have the common property of flowing. Hence, they are termed as fluids. Correct? Then we discuss what is thrust, what is pressure. Pressure is nothing but thrust by area. Thrust is nothing but force only. It is measured in either Newton or gram force or kg weight. Right? That's what we learned in the last class. Now what we have to do? We have to combine these two words. So combine two words and we should know what is the fluid pressure. But before that, there are some more important terms we have discussed in the synopsis 2 about the what is density, what is relative density. Relative will come word when you are comparing. When one is comparing to other. Ramu is good student compared to relative to Sham. What is the meaning? We are comparing. When the two things are compared, then relative word will come. So fluid is given here. Then what is density? The density is nothing but mass per unit volume. Mass per unit volume. Mass by volume is called density. Density is equal to generally represented by rho. Rho is nothing but m by v. So mass per unit volume is known as density. So what is mass is measured in kg, volume is measured in meter cube. Kg by meter cube is the unit, or gram per centimeter cube in CGS system. Right? So density is nothing but mass per unit volume. Mass by volume is known as density. Suppose here there is one condition, special case. What they are saying, for solid bodies, volume and density will be same as that of its constituents of substance of the equal mass. So they take solids because they have particular shape. The volume itself is a mass. Okay, but a hollow body of the body with the air gaps. If M1 is the mass of the liquid of density rho 1 and M2 is the mass of the liquid of, there are two liquids are there with the different densities. Then what we have to do? Volume is total is V1 plus V2. So volume is given by mass by density. M1 by rho 1 by M2 by rho 2. So that is given separately. If the mass are same, if the masses are the mixed, that is they are same, equally mixed. M1 is equal to M2 is equal to M only. You have to M in both cases. So you get the formula as only 2 rho 1 rho 2 by rho 1 plus rho 2 when they are of equal masses. When two liquids of equal masses are mixed. So 500 ml of water, 500 ml of milk, you liquid mixed. Then what is the volume of the liquid? Volume is you can write this formula. So density is nothing but mass per unit volume. It may be of equal volume or it may be of unequal volume of liquids. For solids, there is a mass and volume are same. Right? Now, then again same cases, different cases are. If the V1 is the volume of the liquid of density rho 1, V2 is the volume of density rho 2. Previously, we have taken masses. Here we have taken different volumes. So mass is given by M1 plus M2. So what is mass? Density is equal to mass by volume. So mass is equal to density into volume. So density into volume plus first to second added. From this you can get one formula. If the volumes are same, like mass are same, you are taken. If V1 is equal to V2 is equal to V, substitute here. So you get the same formula. The total density is given by sum of the densities rho 1 plus rho 2 by 2. So whenever the masses are given, volumes are given and asked to find out the density, or when density is given, volume is given, asked to find out the mass, or when densities and volumes are given to find the mass, you can have the formulas here with separate conditions, right? Very important formulas there. Then specific weight or weight density. In place of mass, take weight. Because we know there is a difference between mass and weight. Weight is in terms of the gravitational force only. Right? So that is W by volume. So density is equal to mass by volume. Specific weight is equal to weight by volume. But we know what is weight. Weight is given by formula mg. Mg by V. Right? So you can take m by V is nothing but mass by volume is nothing but density. Density into G. So weight is equal to density into acceleration due to gravity also. Right? There are different formulas. That is, what we are doing is, by combining the various formulas, you get a different number. Now, come to the next part. Relative density. Very important. That is also called specific gravity. Relative, I told already, comparing. So see here. It is defined as ratio of density of given fluid to the density of pure water at 4 degrees Celsius. Because water density at 4 degrees Celsius is constant. So with respect to that constant value, we are finding out the density of the liquids. So relative density is nothing but RD is equal to density of liquid by density of water. Density of a fluid, any fluid it may be, by density of water at 4 degrees Celsius. Constant. Okay. That because this ratio does not have any units because both are density only. So no units. But as we know this value, constant value, definitely you can get this value. For example, you can see here. Then I'll explain you. So the density of water is maximum at 4 degrees and is equal to the value C 1 into 10 power 3 kg per meter cube. The value is constant. That is 1000 we can say. Okay. Relative density of specific gravity is unitless and dimensionless positive scalar quantity. So being a dimensionless unitless physical quantity, RD is a substance same in SI and CGS units system. So specific gravity, same only. Weight. So when it comes in the mass density, you can use the relative density. Specific gravity is nothing but in terms of weight. The ratio of density of given liquid to the density of water at 4 degrees Celsius is termed as relative density, which has no units, and it is a unitless quantity because it's a ratio. Ratios does not have units or dimensions. So before going for the further explanation about this, let me show you one video on the same, that is on density and relative density. Okay.
Density, relative density, and flotation in a simple and practical way. Let's try an interesting experiment. For the experiment, first I will pour honey in the glass. My mom won't be happy with me stealing so much honey from the kitchen. Next, I will pour some water. And now I'm going to pour kerosene. As you can see, we have 3 layers here. Kerosene is above water and honey is below water. Now let's drop in some objects. First, I will drop a steel nail. See, it sinks all the way down. Next, let's put in a grape. You can see that the grape floats on honey but sinks in water. Now let's put in a bottle cap. The bottle cap sinks in kerosene but it's floating in water.
What a beautiful experiment you can see.
And finally, let's put in this plastic ball.
Wow.
The ball floats on kerosene. How is this happening? How do the liquids magically arrange themselves? Why are objects floating in some liquids and sinking in others? Let's rewind the experiment and first look at the liquids. As you can see, water is floating on honey and kerosene is floating on water.
See, this is a very interesting observation you have to make. The liquids, when they are poured in a place, and how they are separated clearly, you can see. Right? So, honey is at bottom, above that water, above that kerosene. So, see, they are above that. If you drop a plastic ball, that ball will float. Some of them are floating on honey and shrinking into kerosene and water. Some of them are floating on water, they are shrinking into kerosene. How interesting this is. All
These
because
three
of
liquids
density.
are not mixing with each other and they form separate layers.
Hi, this is Rup Banjai, the rapper from Chennai. I wanted to have my own studio, but the expense was always going up and up and up and up.
रिलायंस डिजिटल हैप्पीनेस प्रोजेक्ट जोड़ता है भारत का टेक्नोलॉजी से रिश्ता।
Hi, ma'am.
Now, how can we predict if a liquid will float on another liquid? It's based on the density of the liquid. Density of kerosene is less than water. That's why kerosene floats on water. And the density of honey is greater than water. That's why water floats on honey. So whether a liquid floats on another liquid is based on the density of the two liquids. What is density? Density measures the heaviness or lightness of a material. Density is a measure of how tightly packed the particles or molecules of a material are. Density is defined as mass per unit volume. So the formula of density is going to be density equal to mass divided by volume. Density we denote with the symbol rho. Mass with M
Rho.
and volume with V. So our formula becomes rho equal to M divided by V. Now what is the unit of density? You can easily work it out by using the formula. The SI unit of mass is kilogram and the SI unit of volume is meter cube. Density is mass divided by volume. So the SI unit of density is going to be kg per meter cube. The CGS unit of density is also commonly used. And what will be the CGS unit?
Gram per
It's going to be gram per centimeter cube because mass is measured in gram and volume in centimeter cube. So the CGS unit of density is gram per centimeter cube. The density of water in CGS unit is a very simple value. Do you know what it is?
1
It
gram.
is 1 gram per centimeter cube. The density of water is 1 gram per centimeter cube. This means every centimeter cube of water weighs 1 gram. You can visualize this by taking a tiny cube of size 1 centimeter by 1 centimeter by 1 centimeter. And if you fill it with water, the mass of the water in that is going to be 1 gram. So every centimeter cube of water weighs 1 gram. Now, do you know what is the conversion between the CGS and the SI unit of density? That is the conversion between gram per centimeter cube and kg per meter cube. The conversion is 1 gram per centimeter cube is equal to 1000 kg per meter cube. So if you take a big cube of water, which is of size 1 meter by 1 meter by 1 meter, and you fill it with water, then the mass of the water in that cube is going to be 1000 kg, right? So you can easily remember this relation. 1 gram per centimeter cube equals 1000 kg per meter cube because in CGS unit, the size of the cube is very small. It's 1 centimeter cube. But in SI unit, it's a cube of 1 meter cube, right? So this is the important conversion. The density of water is 1 gram per centimeter cube in CGS units, and in SI units, it is 1000 kg per meter cube. The density of kerosene is about 0.8 gram per centimeter cube.
less than 1.
Density of kerosene is less than the density of water, which is 1 gram per centimeter cube.
Mercury
This is why kerosene
13.2.
floats on water. And the density of honey is about 1.4 gram per centimeter
more
cube.
than water.
This is why water floats on honey. So the liquid with lower density will float on the liquid of higher density. There is also the concept of relative density.
What we learned.
Relative density of a substance is the density of the substance in reference with another substance. That is why it is called relative density. Usually the reference substance is taken as water. So the relative density of a substance is the density of the substance divided by the density of water. Now what do you think is the unit of relative density? That's right, it does not have any units since both the units of density will cancel each other.
Ratio.
Now, what do you think will be the relative density of kerosene and honey? Can you work it out? Let's start with the relative density of kerosene. The density of kerosene was about 0.8 gram per centimeter cube. So let's use our relative density formula. It's going to be density of kerosene divided by the density of water. Now the density of water you should substitute as 1 gram per centimeter cube because we are using CGS units, right? So either use CGS units for both densities or SI units. So here our relative density of kerosene is going to be 0.8 gram per centimeter cube divided by 1 gram per centimeter cube. And gram per centimeter cube gets cancelled. So finally the relative density of kerosene is simply going to be 0.8.
It's a mere number.
Now what about honey? Honey had a density of about 1.4 gram per centimeter cube. Again, you can find the relative density by using the formula. So it's going to be density of honey divided by density of water. Once again, the units will cancel each other and we get the relative density of honey as 1.4. So note that relative density does not have any units because the units cancel each other. Relative density is also known as specific gravity. So you can remember that term as well. Just like we saw that a liquid floats on another liquid based on its density, the same concept of flotation can be applied to solid objects floating or sinking in liquids. An object will float in a liquid if the density of the object is less than the liquid, and the object will sink in the liquid if the density of the object is greater than the liquid. Now, based on this concept, can you tell me what will be the density of the steel nail? It is definitely more than the density of all the liquids here because it sinks in all the liquids. And so its density is greater than the density of honey. The density of honey is about 1.4 gram per centimeter cube. And the density of steel is much higher. It's about 8 gram per centimeter cube. This is why the steel nail sinks in honey. Now, what about the density of the grape? Clearly, the density of this grape is greater than water. That's why it sinks in water. But the density of the grape is less than the honey because it's floating on honey. So the density of the grape is greater than 1 gram per centimeter cube and less than 1.4 gram per centimeter cube, the density of honey. Now, how about the density of the bottle cap? It sinks in kerosene but floats on water. So the density of the bottle cap is greater than 0.8 gram per centimeter cube but less than 1 gram per centimeter
Interesting
cube.
observation.
And this orange plastic ball, it clearly is lighter than kerosene. That's why it floats on kerosene. So the density of the plastic ball is definitely less than 0.8 gram per centimeter cube. So we can apply this concept of flotation, that if the density of a solid is greater than the liquid, it will sink in the liquid. And if the density of the solid is less than the liquid, it's going to float in the liquid. So this is the important concept of flotation based on density. If I drop an ice cube in the glass, where will the ice settle? As you can see, the ice sinks in kerosene since density of ice is greater than kerosene. But ice floats in water since density of ice is less than the density of water. Now let me ask you an interesting question. We know that the density of steel is much greater than the density of water and the density of honey. That's why the steel nail sinks in water and honey. Then how does a massive steel ship float in water? According to the condition of flotation, the density of the ship should be less than water. But the ship is made of steel and steel's density is greater than water. Then how is the ship floating in water? Do let me know your answers by putting it in the comments below, and I promise to reply to your answers. So think about this interesting question on density and put the answers in the comments below.
Right. So very interesting. So that is very interesting question. Even though the density of iron with which the ship is made up of is less than the water, more than the water, why boat is not sinking? That is simple because of the streamlining shape that will come across later. there is some law is on that. Principle is there where the shape of the ship makes the ship to float on water. That is called streamlined shape. Okay, it's a very interesting one. There are so many things happen like this. Why aeroplane is given particular shape? To overcome the pressure only. So different bodies which are traveling against the liquid or air, they are given different shape which are called streamlined shape. Right? So that is the reason, the shape is the reason for the floating of the ship in water. See here. So that is, we learn about what is the relative density and what is the specific gravity clearly in the video as well as in the. Till then, we have done with the what is the fluid and what is density, what is relative density. Clear, everyone? Now, we'll come to our lesson name. That is synopsis 3. So, first class we completed synopsis 1, where we discussed about the what is fluid, the basic definition of fluid, and what is thrust, what is pressure, right? So, when you see here, in synopsis 1, the day 1, what we learn is first about what is fluid, the introduction part, then what is thrust, and what is pressure, and its units. Right. Now, today in synopsis 2, what we learn is about, after knowing your pressure, we learn about the what is density, what is relative density, right? And their units of both density and relative density. Clear? These are the topics what we covered in the last 2 sessions of this chapter. Now, after knowing individually about all these things, now we are entering to the synopsis 3, that is fluid pressure combination. So, what type of pressure fluid exert? Either it may be liquid or gas, right? So, see, the term fluid refers any substance which has no definite shape and has ability to flow. That is the definition of fluid. It may be either liquid or gases. Since they have no definite shape and can flow, the pressure exerted by fluid is called fluid pressure. Simple. When you are jumping into the water, when you try to swim, you have to overcome the pressure of the water to move forward. Because the liquid exerts pressure on you. When you are moving against the wind, gases will exert pressure on you, so that you have to apply the more pressure to overcome the air pressure. So many ways you can see where pressure exerts. Pressure exerted by liquid or gases. So what type of pressures they exerted? There are 3 interesting types. Either it is a liquid or gas, they exert downward pressure, upward pressure, and sideward pressure. So the fluid exerts 3 types of pressures. Either it may be gas, liquid, or solid. They exert 3 types of pressures. Suppose you take one balloon filled with liquid, water. Balloon filled with liquid. Another balloon filled with gas or air. Okay. Both are filled and they are bulged. First, put the pin at the bottom. They exert pressure downwards. All the air will come outside and also liquid also come outside. That is downward pressure. The liquid or air exert pressure downwards. Suppose you make side holes. So they'll come out through the side also. Means they exert the pressure on the side walls of the balloon. Suppose if you drop any body into the wall liquid, they upward the upward pressure. Take one rubber ball, drop into the water. When you force also, they'll go up to certain level, they come back. Why they are coming back? Because of the upward pressure of the liquid. It is not only a simple observation, it is a proven, practically proven by so many laws. What way the downward pressure exert, what way the upward pressure exert, what way the sideward, which is also called lateral pressure, exert on a body by either liquids or gases. So very interesting type. Know about the 3 types of fluid pressures, and this leads to some laws also. Some Pascal's law is there, and Bernoulli's principle is there. Archimedes principle also related to this. Even they are helpful for example, when you are crushing the oil is crushed to give the seeds. Oil seeds are crushed to give oil. This crushing is possible because of the pressure only, because of the fluid pressure. So many things will come in our chapter where you can learn about the applications of fluid pressure in our day-to-day life. So lateral pressure. So there is a mathematical expression also given for the liquid pressure. Okay, then total how much pressure acts on a particular area of the body, pressure in fluid, right? Pressure is, there is a mathematical expression for each and everything. Then the Pascal's law, which uses the liquid pressure to, for example, when you go to the four-wheeler showroom, you want to clean your car, there is a pit. They'll take the car under the pit and they lift. The pit will lift the car and they can clean the car with the help of the water. The lifting process is possible because of the pressure exerted by the liquid. Hydraulic, that is called hydraulic machine. Hydro means water, with water pressure. This hydraulics also used for crushing the oil seeds into oil. So many are there. So they are called gauges, absolute pressure. There are so many types of pressures you can see in our day-to-day life that we'll discuss one by one. Okay. So gauge pressure, manometer to measure the pressure, barometer, manometer, all comes under the measuring devices to measure the pressure. Okay. So see how the upward pressure, downward pressure, lateral pressure acting in the diagram. Very interesting things are there in the chapter to know more and more about the pressure exerted by the liquids. Right? So, fluids are the state of matter which has common property of flowing, which flow. So, while flowing, they exert pressure on each other, on other state of matters also. So there, the reason for that is density. Density is the reason for either floating or shrinking of the body. And the density also can be found by the one substances with respect to other can be found by relative density. Okay. Then types of pressures. The fluid pressure is pressure exerted by the fluid, that is either liquid or gas. There are three types of pressures: upward, downward, and lateral pressures, which commonly you can see simple experiments. These all pressures are responsible, either body is completely shrink into the matter liquid or floating over the liquid or partially sinking. So based on this, there are so many principles are proposed. Pascal's law, Archimedes principle, Bernoulli's principle. All these are, for example, when the cricketer is bowling the ball, why ball is swinging or spinning? That is because of the pressure of the air. The air pressure is the responsible for the spinning of the ball. That is explained by Bernoulli's principle. So many things are there. Okay, we learn in the coming sessions. Right. So this is the home task for you. Define density and relative density. Write their units and mathematical formulas from your materials. Note down in notebook. And take the corrections from your teachers and parents. Right. So that's all for today. Thank you, all of you. Have a wonderful day. Thank you.